Welcome to another video on Smart Architectural Programming, the home for clear, concise Java tutorials designed to accompany your learning journey with our book, Introduction to Java. In today's video, we're diving into an important object-oriented design concept, designing a custom immutable type in Java. If you've ever wondered how to create safe, thread-friendly, and robust Java objects, you're in the right place. Let's get into it. So, to understand custom classes in Java, first we need to understand what is an immutable class. An immutable class is one where instances cannot be modified after they're created. Once the constructor finishes execution, the state of the object is set in stone. Here are key characteristics of immutable classes. All fields are private and final. No setter methods. The class is marked final, so no subclass can alter behavior. The class returns deep copies for mutable fields, not the original reference. And all initialization is done in the constructor itself. What does this mean? This means this is one hell of a feature and one hell of a powerful method that you can use in your programming endeavors in Java. The most well-known example in Java of an immutable class is the string class. It's immutable, thread-safe, and a gold standard for all value type methods. So, next thing to understand is why immutability matters. So why do you go through all of this trouble, right? Because immutability offers us three very important things. Thread safety without needing synchronization. Easier debugging, no unexpected changes to object state. And safe sharing of objects across classes, layers, or threads. So this is a very crucial aspect of what we're talking about, an immutability. It's especially crucial in concurrent programming, functional programming, and domain-driven designs. And again, you don't need to understand what they are, but what you do need to understand is their importance in making sure, how we push forward. So next thing is how you can build an immutable class, an example for that, right? So this is a simple immutable class we built here. Let me get my, So let me get my pen here. Let's use a color that's a little bit, that makes a little more sense here. And yeah. So, all right. If you focus yeah, sorry about that. We're moving back and forth. So let's come back. Yeah, having some technical issues here. So let's use this pen here. So you see this class here, person. This person class is very, very essential because we're building this class to explain how immutable classes work in Java. So looking here, what you need to understand and focus on are some aspects that are going to be important in this particular code base that we're going to go over. So let's highlight those aspects that you need to take a look at. You need to look at the fact that the class is final here. No one can extend it. The fields are private and final as well. Constructor does deep copy of hobbies list, and getters return copies, not internal references. So you look here, we have a person class here. We have a private final string name. We have a private final int age. We have a private final list string, which is called hobbies, right? And then we have another public method here that has certain variables in that, right? So with that, and this particular thing allows for deep copies, basically, right? So then we have the name method, get age method, and arrays, and then this return copy here. So all of this basically implies all of the four aspects that we discussed here, and you just need to look deeper into the code to understand exactly what's happening here. So let's look into the next section and try to understand where we need to get to. So the next thing we need to focus on is basically, so we need to remove all of this here. Let's clear the field, or let's just close this. So yeah, ignore those red lines here for now. So basically what you need to understand is that there's a tricky aspect to this as well. How do you ensure deep copy for mutable fields, right? That's the challenge here. And to do that, it's basically, yeah, here it is. Let me delete all of these sections here. I mean, doing that is quite simple, basically. So, what you need to understand with the tricky part of mutable about this is their mutable fields. Java has objects like list, map, or custom types that can be mutated after construction. If you just assign them directly, your class is not truly immutable. And to fix this, it's quite simple. In the constructor, you can make deep copies to fix this mutability aspect to it, right? In the getter, you can return a copy instead of the original. Let's look at what not to do. So again, let's get our pen here and, let's use a highlighter here instead. So this is what you cannot do. It's dangerous, and that's how you make the wrong implementation. We're using this dot hobbies equals to hobby. But the safer way to do this, basically, because this particular method here, and let's use a little bit different of the draw tool we need. So basically, this particular tool over here is what we call a situation where a caller can change the object's internal state. So if we use a caller here, this can change the internal state of the object. So always, instead of that, the best way to move forward is to use this. Let's just get the highlighter. That makes more sense here. Thicker highlighter, and this is what we need to use. This is the best way to avoid any such situations where basically your caller can change the internal state of the object. So let's erase all of these lines here so we don't have to see these again. This one, green one here, and this red one here. So with that, let's go to the next page and discuss the final aspect to this video, which is a checklist for immutability. Because you need to summarize the immutability checklist you need to follow. So you first need to understand is that all of this is essential. So you have this on hand so you can verify and check for immutability of your objects, right? So let's go over this checklist one by one. You need to declare the class as final. You need to make all fields private and final. Don't provide setters. Initialize all fields in the constructor. Use deep copies for mutable objects. Return copies in getters for mutable fields. And avoid exposing internal references. If your class follows these rules, it's safe and it's considered immutable. And I think with that, we're going to wrap up this video. So, or rather before that, actually, we have one more section here, which is when should you use immutable classes? Honestly, wherever you don't want any shenanigans to go on. By shenanigans, wherever you don't want things to actually, be changed, right? So use immutability when you need thread safety without locking. You're working with value objects like money, point, or name that can't be changed by anyone, right? You're building objects in functional style or using streams, or you just want to simplify the reasoning about the states. So that is when you need to use. And at this point, I want to give you a bonus here, a little bonus about Java records. So Java records were introduced in Java 14 plus, right? Which is a special kind of class that's immutable by default. You don't need to make it immutable. It's already immutable. This auto generates final fields, a constructor, and getters, perfect for simple immutable types. But be careful. If your fields are mutable objects, you still need to ensure deep copies manual. So just keep that in mind. To wrap up, designing immutable types is one of the most effective tools in Java for building robust, thread-safe, and maintainable code. Start small, convert your DTOs or value objects to immutable types, and you'll see the benefits. If you like this breakdown, give us a thumbs up, hit the subscribe, and check out our book, Introduction to Java for Deeper Practice. Here, have questions, or want coding samples? Drop it in the comments. We reply to every one of those. Thanks for watching, and keep coding smart. And see you in the next video. Thank you.